Alright guys, so we're going to do a quick video here to cover what we missed in class, and that was representing the graphs of polar equations as rectangular equations. So right here, what that's going to mean is taking an equation like the one we've got right here, which is the equation we graphed above, and substituting some combination of x and y values for r and for theta. Okay, so right here, what we want to do is first figure out a way to relate r and theta for a polar point to x and y values for the rectangular point, right? So again, we're going to do this with vectors. Right here, if we've got some polar point, r theta, then right here we can extend a vector out to that point, and we know that the magnitude of that vector is going to be r, and the direction of that vector is going to be theta, right? So right here we can say that right here, representing this in component form is going to give us a horizontal component of r cosine theta and a vertical component of r sine theta. And since we have standard representation here with our tail at the origin and our head at the point, what we can basically say is that the horizontal component is really going to be the x value of the ordered pair at the head. And of course, the vertical component is going to be the y value of the ordered pair at the head. Right? So in general right here, what we can say is that x is really going to equal r cosine theta, and y is going to equal r sine theta. Right? We can also relate r to x and y directly by using the Pythagorean theorem. Right? So if we drop a perpendicular from our point, right, we've got the length x right here as being one of the shorter sides of the right triangle, the length y as being the other of the two shorter sides, and r as being the hypotenuse for a right reference triangle right here. And so right here what we can say then is that using the Pythagorean theorem, r squared equals x squared plus y squared. Right? So using these two things, we're going to be able to manipulate our polar equation a little bit and come up with some substitutions that is going to change the equation from being defined by r and theta to being defined by x and y. So right here, we're starting out with r equals 2 sine theta. What we'd like to see is that r squared, right? Similarly, it would also help us out if this were an r sine theta instead of a sine theta. So to get that r squared and that r sine theta, we can multiply r on both sides, and we're going to get r times r equals right here 2 sine theta times r. That gives us r squared equals 2r sine theta. And right here, we can then start to make some substitutions. We know r squared is going to be x squared plus y squared. And right here we can say r sine theta is going to be equal to y, so we've got 2y on this side. And there we are. We've got a rectangular equation defining our graph, right? Now, in general right here, what I would say is that if we think about what our polar equation represented, it was right here a circle, right, with its center somewhere on the y-axis, a radius of 1, and we could say that that center is actually at 0, 1, because right here we can say that the diameter of the circle stretches from the origin, 0, 0, to right here a maximum height of 0, 2, right? So if that's the diameter, then right here the center would have to be 0, 1. And what I would like to do is challenge you guys to write the equation we're seeing right here, the rectangular equation defining that circle, as the general form of a circle that we normally see, x minus h squared plus y minus k squared equals r squared, where h, k is the center, and right here, r is the radius. So right here, that's my challenge to you guys. I want to see if you can represent our rectangular equation in the form of that x minus h squared plus y minus k squared equals r squared that we normally think of when we think of the equation for a circle. I'm also going to give you guys some of these for homework. Again, our general strategy right here is to try to get r squareds and r cosine thetas and r sine thetas. And generally we're going to get that by multiplying on both sides by r in some way to get us those r squareds, our cosine theta, and our sine theta that we can then substitute those x and y values for. Alright guys, so that's our video. I'm going to post this with the homework, and we'll look at this stuff tomorrow.